Okay, so like I said, we're going to kind of go a little bit out of order, and we're going to skip to circles today. And then next week, when we come back, we'll get into the polygon stuff that we skipped over. So we're going to go over how to find area of a circle today, but we're also going to talk about how to find area of something called a circle sector. And before we get too far into this, I actually have a YouTube video that we're going to watch that goes over where the area formula for a circle comes from. Just like we've talked about, where did the formula come from for rectangles and parallelograms and triangles and trapezoids? We did all that work the last couple of days. This video that I'm going to play is going to show you guys where they got the area of a circle from, the formula. So I'm going to switch over to that really quick. Hopefully you understood the idea of what they were doing with that circle is they were cutting it into slices. And the more slices that you cut it into, the more perfect of a rectangle that you get. And they said in there that in order to actually create a perfect rectangle, you would have to cut that circle an infinite number of times. Could we actually do that though? Could any of us actually cut a circle infinitely? No, it's impossible to do that because it would have to go on forever and ever and ever and ever and ever, and we can't do that. So when we think about how they got that formula, they kind of showed you that you're using that radius again from the circle, and that was the same as that height of the rectangle. And then they talked about circumference. Remember, we went over circumference on Monday, where that was all around the circle. And that formula was like pi times diameter, or it was 2 pi r. They chose 2 pi r to keep it related to that radius that we already had for the height. So our formula, like they said in that video for our circle, is it's just pi r squared because the 2 is canceled off. So here on your guys' notes, you can write pi r squared for our formula. Okay, and I kind of have that picture like they showed in that video of you're slicing that circle up into these pieces, you're arranging them in a way. Maybe you even noticed at the beginning, like when they cut it only a couple times, it looked like a parallelogram. And then the more times they started cutting it, it started to get more rectangular shaped because you had more and more of these like smaller sections that you were working with. But the formula that we have for a full circle is pi r squared. Now, you don't have a second formula for a circle that deals with diameter. So when we did circumference, we had pi times diameter, or we had 2 pi r. We were able to use either one of those for circumference. We do not have a formula that deals with diameter on a circle when you're talking about area. You have to use the radius. So if the circle is giving you the diameter, what do you need to do to that number to get to your radius? Split it in half. So make sure if you're dealing with a circle and you're given diameter that you cut that number in half before you start plugging it into your formula. Because if you plug it in with the diameter, you're going to get an answer that's way too big. Now let's talk about these other things here, which are these circle sectors. So a circle sector is like a piece of the circle that I'm looking at. So I'm not looking at all of it. Think about if you had like a pizza, okay, and you cut it up into slices and you take away 3 pieces. And you were trying to figure out like the area of the amount that you took away, that would be your sector. That'd be the amount that you took away from the entire pizza. So when we look at these problems down here, how much of the circle on this first one is shaded in? Half of it is. So if you could think about this with me on the inside here, how much would this, like from this side of the radius or the diameter over here to this side, how many degrees is that? 180, because it's half of a circle. Okay, do you guys know how many degrees are in a full circle? 360. So if I think about 180 divided by 360, what would that reduce to? 1/2. So if you're thinking about area of a full circle, but you're only dealing with half, we would be multiplying it by half or dividing by 2. So I would think my area would look like this: 1/2 times pi r squared. Now, I don't actually know the radius right now, so I can't find the area of this sector yet. If they gave me that information, then I could start plugging that in. But if I see half of a circle, it would be that 180 over 360 reduces down to 1/2. What's going on my second one here? It's a fourth. Because how many degrees would this one be? This would be 90. And so you said a fourth because 90 over 360 is the same as a quarter. So how would we write this formula down here? 1/4 pi r squared. Okay, so we've done that for half a circle. We've done that for a quarter of a circle. Do you think we could do that for any portion of a circle that we have?
Yeah.
What do we need to know in order to do that? We need to know how much of the circle they have, whether it's 90 degrees, 180, or it could be something totally random like 19 degrees. Or it could be something like 230 degrees. It's got to be somewhere between 0 and 360, though, because we know that's how many degrees are in a circle. So if you look at this last one, they're giving you this sector that's 49 degrees. So how would you write this out as the formula like what we've been doing with the last couple? Well, is it 1/8? Is 49 divided by 360 1/8?
Looks like 1/8.
Do you have a calculator?
Well,
Keegan's got it. Can you take 49 divided by 180?
0.272.
So hit that button above your enter sign. Does it turn it to a fraction for you?
49/180.
So it doesn't reduce to 1/8. So it's not truly 1/8. Now maybe it's close. Okay, we might be close to that. But I would do 49 over what? 360, because that's how many degrees are in a circle, times what?
Pi r squared.
Pi r squared. So these three are all similar. It just really depends on how much of your sector you have. So let's think about how we could write a generic formula that we could use for any situation. We started out by taking our angle divided by 360. What could we use to represent the angle? If we don't know what it could possibly be. It could be anything.
The circle.
Yeah, do you remember what that's called?
Theta.
Theta. We could use theta. You could use x if you wanted to represent that angle, but a lot of times when we're talking about an angle, we might see that Greek letter show up again, theta. And we would divide that by what number? 360. Okay, sometimes it would reduce nicely, sometimes it doesn't. And we continue to take it times what? Pi r squared. So if you're not dealing with a full circle and you're just dealing with a partial piece, you're going to take that angle of your sector divided by 360 times pi r squared. So what we're going to do now is a couple of examples. And they're either going to want you to find the area of the whole circle or they're going to want you to do the sector. Now, when they have like a sector piece, usually they'll have that part shaded in just to kind of distinguish, like, I don't want you to find all of it. I just want you to find this piece. So if you look at the first one, it's not shaded in, which means they want you to find the area of the whole thing. So how would we do that here for this first one? Just a regular circle. So what's our formula?
15 squared.
Pi 15 squared. Okay, again, notice down here they've got that e, so they want an exact answer, so I don't want you to multiply by pi. So what's the other thing you need to do here?
The squared.
So what is 15 squared?
225.
225. And then we would add pi on. And I'm still dealing with area, so what's my label? Good, still centimeter squared. Now the second one is not a full circle anymore. Do you see how some of it's kind of shaded in on my screen? Yours is maybe a little bit harder to see just because yours isn't in color. But they only want me to find the area of this shaded region. So what do I need to do here?
3/4.
How'd you get 3/4?
270.
270 over what?
360.
Which does reduce to 3/4. So if you want to think of it like that, that's fine. But if you don't know for sure, you can just still type it in your calculator like that. It's going to work the same way. And then what? Times what?
Pi r squared.
What is the r?
2.
2. Again, we're not multiplying with pi because they want me to have an exact answer again. So 2 squared is 4, and you're taking that times that 3/4 or 270 over 360.
3.
That just becomes a 3?
Yeah.
And then what's attached to my 3?
Pi.
Pi, and my label?
Centimeter squared.
Centimeter squared. Okay, this whole piece here and this you could type into your calculator. So if your numbers start to get a little bit more obscure and maybe you can't reduce nicely, like we could on this one, we could see that it's 3/4 of a circle. But if they gave you like 271 degrees, that's not going to reduce super nice. So then you might want to go to your calculator and type it in to see what they get you as a fraction. All right, let's talk about this last one. Nothing is shaded in, which tells me they want the area of this entire shape here. What are we working with on this shape? A rectangle and a half circle or a semicircle. Okay, so let's talk about how we would find the area of the rectangle. So let's start here. How would you guys find the area of that shape?
6 times 10.
6 times 20, which is what? 120. Okay, so I'm going to write that down over here. Area of my rectangle would be 6 times 20, which is 120 centimeters squared. Okay, now let's deal with the semicircle. So this piece up here,
1/2 pi 10 squared.
okay, so you said 1/2 pi 10 squared. So why is she saying a half?
Because it's a semicircle.
Because it's a semicircle. Where did the 10 come from?
Half the 20.
Because 20 is the what?
The
What'd you say? Diameter. So we have to cut that in half, and that's where she got 10 from. She's saying that from the center of the circle to the edge here is 10. So what does this become? Okay. Now I want to find total area, so what do I need to do with those pieces? Add them. Now how do I do that though? How do I write that down here? 50 pi plus 120, or you could do 120 plus 50 pi. But you're not actually going to add the 120 and the 50, because remember that's got the pi on it, so we can't put it together. So I'm going to leave them separated. I'm just going to write 120 plus 50 pi. And what's my label? Centimeter squared. Are you guys okay? Are you confused? He's good now? Okay. All right. Do we have questions on finding area of a circle or its sector? Okay. I'm going to get you guys your worksheet.